We've been discussing a little bit about AI and data. And one thing I'd love to talk about is the myths around AI. And like everything we see in the news is kind of like AI is going to take over your job. AI is taking over this. AI is doing this. And I'd love to hear your thoughts behind that. And anything you also have seen in the news where you're like, yeah, that's so wrong.
No, and I think that's hard. That's a good question. It's hard in a very evolving field, right? But I think if we start off with just the fundamentals of what is it, right? How does this even work, right? It's a black box for so many people. And so if we take a step back, one of the ways I always think about it is like, it's called, I think, a Gallatin board. So in essence, it's this board with all these pins on it. It's like a pyramid. There's all these little nails on it, and you drop a ball, and the ball bounces through the board. So, and if you do this, right, it is often used to show like a statistical distribution. Because if you put 50 balls on it and they all fall down, they all have a 50-50 chance to go left and right. In the end of the day, what you have is you have this curve, a bell curve, like a standard, distribution curve. And I use that to think of how large language models work. So in essence, your prompt, the question you're asking, it's like the ball. It drops in and it goes left or right. And when we talk about fine-tuning and training, we're talking about weights and how we adjust, they're going to the left or going to the right a little bit. And so maybe, for the first nail it hits, I want it to go right at a 30% chance and, left at a 70% chance. The next one, I want to go, and you apply all these different weights, and it's not just two-dimensional, it's actually hundreds of dimensions, so we can't really think about it anymore as a human brain. But that's in essence how the decisions are then made of what is the most likely response to the prompt. It's a machine, and the prompt drops through the machine. And, the engineers that build it, they controlled if it goes left and right. In the unsupervised learning models, we don't go as detailed anymore as fine-tuning every variable in there. It's like 500 billion of these nails in essence that the ball drops on and it goes left or right. So it's not really humanly possible to control all of them, or at least it wouldn't create a very good outcome. So we have these unsupervised learning models, but we check on the outcome, right? We check if it got better or not. And we, in essence, run the same tests, millions of times to really fine tune it. That's the machine. That's the black box, right? And so what does that mean? It means that it is trained on taking something and creating an output. And it's very good if it has seen the pattern many times before. An example is in your photo album, right? In your photos, like, this magical new feature where you can actually remove a person in the background. The way, generative AI does that is it determines what is behind, what does the background look like in other places, other pictures or in that picture. And it extrapolates out that probably the background is also a tree, or a scrub. And so it can remove that person and just fill in the blank. One of the most common training ways of how we train the large language models is you take like Wikipedia and you remove every third word. And then you run it through the machine to say, hey, autocomplete every third word. And it got pretty good at that. And then we said, okay, let's take away every other paragraph. Or maybe first every other sentence. And you autocomplete the sentences. And then you autocomplete the paragraphs. And after a while, the machine knows pretty good, like what it should put in there, but it's always trained on how humans would have done it. And it's always trained on pre-existing data sets. And that's like, it's dependent on us providing good data. So in the history of humankind, right, we would have never been able to build this AI because we never had so much data easily available. Like this is like now, the last couple years, we have been putting so much data accessible to everybody, or to the, in the internet, or digitally accessible. And now we're able to train these massive data sets, these massive LLMs on massive data sets. So I think that's a super important thing to understand, that's what it is. It's not a black box. It's a black box in a sense that nobody can fully understand all 500 billion, decisions are like variable hits.
But So if you're not able to understand all these 500 different variable hits, but isn't sort of your code kind of giving you the parameters and of like exactly what it should do? So shouldn't you have an idea of
Yeah.
what it should do?
No, and that's the thing. Right? It's so crazy. Like you ask the same question 600 times and you get different outcomes almost every single time, right? Because imagine this ball falling through the board, right? Like if you drop 50 balls that are all the same, you in the end have this distribution. Like they're all over the place. Like if you take one specific ball and you want to see where it landed, it might land over here. It might land over there. Most likely it's going to be somewhere in the middle. Right? Like, so I can't predict where the ball is going to go because each time it hits one of the decision points, there's a 30% chance it goes this way. There's a 70% chance it goes that way. So I'm very sure, I'm 70% sure it goes this way. But if I ask 100 times, I have 30 balls going the other way because there's a 30% chance it goes the other way. Right? So the reason it's built this way is so it can handle many, many different questions. Right? Like in the old school of engineering, you only had one path, and you knew that a ball drops in, it always comes out right there. And that works really well for very rigid use cases, very specific things where you always want it done the same way. Like imagine a machine that builds a screw, right? You always want the screw to be exactly the same way. But this tool, generative AI, large language models, was built to take fuzzy inputs, like all kinds of different inputs. And the reason it can do it is because it wasn't built in a rigid way. It was built in a kind of fluid way. And so now you can throw all kinds of inputs in. Downside, you get all kinds of outputs out, right? So one way you control this is called the temperature. So the temperature says, I want you to go wide or I want you to go narrow in what comes out of this. Going wide means that the large language model might come up with some very creative ideas, very like kind of out there ideas. Going very narrow means like, okay, it's probably going to be pretty cookie cutter kind of answer. It's kind of similar to a person, if you hire someone who is like, they're trained in this one way of thinking, like that's a very, kind of expect what the answer will be versus someone who, maybe they're a more liberal arts education, they come up with all kinds of ideas. Yeah. So it depends on what you want.
So can you go a little bit more into the temperature? What is like, I understand what you're saying, wide and like kind of giving the large language model more freedom to make a decision versus being really strict and rigid. What is temperature? Can you explain that a little bit more, please?
Yeah. So let's take an example, a very simple example. An autocomplete, right? Like an autocomplete is, we all know it, right? You start, now we all know it, right? 10 years ago or 15 years ago, it was kind of like magic. Like I typed in, see you later, right? Or, so the next month, what is the next likely word? Okay, see you. After see you, what is the most likely word to come? Later. Right? And if you know American English, then later is the most likely word to come. If you go with a wider temperature, it would come up with some like more creative ideas of how it could be completed. Like see you later, alligator. And like the alligator edition is like a more creative thing to add to it, a little bit more out there. And the large language model calculates what is the most likely response that you want to hear. So it does some math on like, every single time it hits one of those nail pins in our skeleton board, right? There's a total percentage, like the outcome that you get at the end, right? Let's say it gives it a 3% chance that this is the correct answer. And, it has 16 other versions, maybe even more. And it gives each one a percentage of what it thinks, how likely it is that that's what you want to hear. And then it gives you the one that it feels very comfortable with. With a high temperature, it goes out there and comes up with some yeah, see you later, alligator, a little bit more out there kind of ideas. Some of the UIs, like when Google Bard came out and the UI for Bard, which is now branded as Gemini, you could see the different drafts, and I thought it was kind of a neat thing to do. And it's a good educational tool.
The user could see all the different drafts that the AI was, or the large language model was making.
Yeah, so it would give you three, and it would give you the three most likely one. And first of all, I think that's a really good way to use user feedback. Like, oh, you know what? I actually want to hear this one, and that way we can train the model a little bit better on that. But it also, I think, shows me as a human that there are different answers. There's not one correct answer, right? There's like three things that are highly likely to be the correct answer. And so, one thing a lot of people get frustrated with is like, wait, the AI just lied to me. Like, it was wrong. Like, how can it lie to me? It's like, no, the AI predicted that you wanted to hear A, B, and C. Like, here's a good example. So we implemented this internally, and then our sales team used this tool. Well, actually, I tried it out, and I just imagined what the sales team would be doing. So you ask the tool, how much revenue did we make last quarter, right? And then based on the information the AI has, it predicts what you want to hear, right? That's very different from a calculator. Like when you ask a calculator, what is 4 times 5? It says 20. It doesn't run through calculations to figure out what you probably want to hear. It just does math, right? It's a very straightforward, purpose-built tool. Generative AI, however, it doesn't necessarily do the math. It thinks about what do you want to hear. And so, there are a couple of things you can do to make it more accurate. One is like, hey, show me the steps that you're going to take, right? Like, so let's say, like you're at a mid-sized company and you have the AI connected to your internal documentation and spreadsheets, and you ask it, how much revenue did we make last quarter? Right? The AI probably knows that you're usually around, like, let's say $10 million. Right? Just making up a number here. So now it would go and just predict that that's probably what you want to hear. Like, it doesn't necessarily do the math for you. Like, we really have to set up the systems correctly to make sure that there's actually some analysis done and not just things being pulled out of the hat, right? Like, one of the ways I often think of the AI, at least in the state it is right now, is like an overly eager intern that had a lot of coffee. Okay. Like this young guy with a bunch of coffee in his hands, and it's like, oh, you want to know how much revenue we made? Oh, we made 10 million. I'm so sure, So like that in mind, like that's the AI as it stands right now, right? It's a people pleaser. It was trained on being really nice and good and like, so it's a people pleaser. And it's a lot of coffee, and there's no checks and balances.
So with ChatGPT, they have this new like enterprise thing where a company can come in and it's just for internal use, I believe. And you can upload documents like your 10K and like all of that stuff. But is this something you have to keep updating, or can the large language model eventually like figure out where to pull this data from and then give it to you? Or is this always going to be something where people have to manually enter in all of these documentations?
It depends on the system architecture and how you set it up. Like I set up a system on my own drive, right, on my own drive with my documents in it, and it automatically indexes and applies vectors to my documents. So, but yeah, I do have to put anything in there, right? It doesn't just take it out of my email. You can set it up that way. Like you can certainly say, okay, automatically add any kind of attachments I got in my email, automatically add, any kind of email I got even, or any kind of chat communication I had. It depends on, what kind of access you want to give, your AI in your enterprise. And then, you do have to also, in your architecture, you can set up things um, where the AI, right, the large language model is not the only component of the solution. So you have the generative AI model, like let's say you're using GPT-4 or using Google Gemini, but that's one piece of it. But you have other pieces added to it, right? Like there is probably a chain or an orchestration happening where you want to make sure that okay, this question is a mathematical question or an analytical question, and therefore I'm putting restrictions on what kind of imagination the generative AI can use. But the generative AI might be really good at understanding what the person is actually asking, but I mean, you're an analyst too, right? Like so many times what people ask is not exactly what they mean by that, so being able to translate that into kind of like a query or a spreadsheet and what it would look like in a pivot table. I think that's where the Gen AI could be very powerful, but then you may want to add to it like a traditional SQL engine that actually then writes the SQL and executes it and gets that back. I mean, the Gen AI can write the SQL probably too. You just want to have some guardrails around it of how things are defined.
So I want to kind of go back to our earlier conversation, and you were talking about patterns, that the model can like figure out these patterns, and you can give it kind of a big scope to play with or really restrict. With that, I'm curious what your thoughts are with decision making in AI and allowing an AI to make decisions. So, in particular, I'm thinking like self-driving cars. Um, like how does that work?
Yeah. Yeah, I mean, I think a lot of times the questions comes up on the ethics of AI, right? Like how do we compare this? Who is responsible? And I think the vast majority of systems I see, I would call them a human in the loop, system where two things, right? Like humans constantly make mistakes. Like there's constantly someone who you shouldn't have written that email, or you shouldn't have said it that way, or worst case, like to the car example, right? Every day there's horrible crashes everywhere, right? And so people make mistakes, and the same way, a computer that has to take all these variables into consideration might make a mistake, where in hindsight, that was probably not the best path to take. That said, I do think you can probably set up a computer pretty well to take a lot of things into consideration. But in the end of the day, a decision has to come out, right? Like there has to be some sort of like, okay, I'm going to hit the brakes, or I'm going to go to the right, or I'm going to go to the left, right? Like a decision has to be made. That's why I think a lot of times right now, at least from a regulatory perspective, there's still a human with hands on the wheel that has to make a final decision. I think it's a really interesting one of like who is responsible, right? Like you can't, I don't think you can build a perfect computer, that is always going to be right on everything, because we don't even know as humans what is right all the time, like decisions that were made 30 years ago, we might not consider as the right decisions anymore now, or if you look at an election, right, like a different cycle and different people believe different things. So what is right and what is wrong is a fluid state. And so, I mean, now we're getting into philosophical, but it's, yeah, like if you go into, 500 billion variables, but you're trying to take every possible permutation into account, I don't think we'll ever have like a complete, like what is it called? Infallible, like something that is just beyond being ever wrong, right? You will never have that. And the same with a human, right? You never have a human that is never wrong.
Yeah, that makes sense. And that's interesting because I see a lot of stuff about military and where AI is going to help with safety and all that stuff, but the military is pretty advanced in itself.
I'm thinking, so, okay, here's a little bit me going on a personal tangent. So we are spending as humankinds, right? Like as humanity, we're spending a lot of resources on military, right? Like against each other in essence. We're spending a lot of resources on marketing, right? Social media, marketing, try to advertise to each other that your life isn't as great as you think it is and you should buy something to make it better, right? So we're spending a lot of resources on those things. But like, there's a lot of stuff we could do, like the MRI example, right? AI for medical research. Like, we still pretty much, our life expectancy is around 85 or so, right? Like it used to be 75, now it's 85 with like 100 years of research. We haven't made all that much like progress, like physics, right? Like gravity. Like last time someone made any kind of breakthrough on how to like on gravity was Einstein, right? That was a long time ago. Like, and there's so many things where humanity could apply itself a bit more, and maybe AI can help us with that, right? But I think there are very interesting scenarios we can tackle, like in discovery of medicine and in physics and testing on like molecules and all these different things where I think AI is quite interesting to be applied.
Yeah, I like that. And I'd like to go a little bit deeper into that. So you mentioned medicine and healthcare and how AI can kind of make life a little bit easier for healthcare, or like you can optimize better, you can get better results, or
Yeah. So healthcare is a huge industry, right? It's very expensive. A huge chunk of healthcare is actually in bureaucracy, right? Figuring out claims processing and whatnot. I think that can be done. A lot of that can be done with AI, like understanding what really the conditions were, right? Like I know one challenge is getting doctors into remote places, like remote places in the US, but also remote places in the world, right? Like there's currently really no qualified doctor who wants to be in a remote town in Afghanistan, right? Like you can't get anyone to go there. So can you have people supported by AI that tell the person, hey, you know what, based on the symptoms, I think this child has malnutrition and we need to give it like a peanut butter, calorie bar every day. Based on the symptoms, they might have like a stomach worm or something, right? Like I think an AI system is quite good at seeing certain patterns. Like, hey, this child is experiencing this symptom, and this symptom. Therefore, it's probably going to be this situation, and we can help the child with these and these course of action. That's a really good example of a perfect thing AI could do. I was talking to some doctors here in the US, and they were like, "Oh, like, oh, no, like, we are needed." And I think they're needed because when I go into a doctor, I do want to talk to a person, right? I like that. It's important to me. There's a person, but I also would like to have, the Google super AI behind it that also tells the doctor, hey, you know what? I read the last 3 research papers that came out in the last 3 months on this condition. And I know you were busy, Mr. Doctor. So let me just quickly summarize you that currently, based on the sickness that came over from Malaysia, this might actually be X, Y, and Z. And this doctor who hasn't been in school for 15 years, right, might not be up to date on all the latest and greatest. So them working together, I think, is quite an interesting scenario for someone like in the United States. I asked the same doctors about my Afghanistan child situation, and everybody's like, oh yeah, absolutely, that totally makes sense. Let's send AI into remote towns in developing countries. So I think they were thinking a lot about their own jobs, but in the grand scheme of things, right, there's a lot of people in need for qualified medical advice. So that could be huge. Like the vast majority of the world does not have qualified doctors. So having some sort of like support there, I think would be really good. Handling claims, any kind of dealing between insurance policies, what insurance policies said and what the doctor did, doctor's notes, any kind of, there's so much happening there that is overhead really and shouldn't be that expensive. And then, I talked to one doctor and he says he has like 10 minutes or 5 minutes to review these thousands of MRI images. That's a great example, right? He has no time to really be thorough on that. How scary is that? Like a highly paid doctor, he has to tell me if I have maybe some cancer or something, and he actually doesn't have the time. It would take an AI 5 seconds to review all the images, and it would do quite a good job of comparing it against thousands of patterns it has seen before.
That isn't a field that I feel pretty optimistic about, where AI can add a lot of benefits, especially since hospitals are crazy most of the time, and there's so many moving pieces, and an AI can work around the clock 24/7 all the time, that being able to like allow doctors to be with their patients rather than like trying to read through all these scans and then tell them that, hey, I didn't see anything, and then, oh, wait, I went back to the scans, I do see something. Like that's pretty crazy, and that's changing somebody's life. Being able to have AI helping alleviate some of that stress and overhead, I think will be really beneficial. While we were talking, I was just kind of thinking of different industries where I think AI would be really interesting, but I'm curious what you think about construction. Like where, I know where could AI benefit construction?
Interesting question. So the reason I think it's an interesting question is because like when I think of, after all we talked about with AI, where we say, okay, like anything that has to do with text recognition, patterns, right? Like that's a great use case for AI. like construction is not what came to mind, right? Like I think the top industries that like are currently being identified is of course technology itself, right? Writing code, everything in technology is based on technology, so it's very easy to plug AI into that. Financial services, very structured, very data driven, very underwriting policies, like all of that. And then retail, just because retail is so big and a decent chunk of retail is marketing, right? There's forecasting, logistics, supply chain. So these are the three big industries that are going to be impacted. The one that's probably the least impacted of all is construction. It's like at the very bottom, right before agriculture, I think. So agriculture has a bit of an AI component to it in terms of forecasting what the, like how much water is needed here. How can I use satellite images to detect certain issues, weather pattern, harvesting forecasts, those things. But those are very like normal AI. It's not generative AI, where like generative AI is more of the, take a fuzzy thing and come up with something that's also a little bit fuzzy. So tell me a bit more about your question on construction.
I think the thought behind it is that I think AI is going to touch a lot of different aspects of different businesses. And like you said, financial and banking and all of that stuff, technology, it's going to change, and it's changing now. Healthcare, I think it's going to be really beneficial. Education, I think it's going to add a lot of value for any education. I think it's going to be able to create these decks and help students learn. And like I've even used it in my own personal, like, hey, can you test me on X, Y, and Z? Like, how do I do this? What's this look like? And how does this look? And I think it's going to help us be better at writing. It's pretty good with code for basic level code. I think it does a really good job, and it still is really good at editing your code. But construction is the one where I'm like, okay, where could it add value? Like, and I'm thinking like mining, I'm thinking like construction of homes. And I guess with homes, I'm thinking, okay, so if you give it some framework and this is what the blueprint looks like, what do you think? What's going to give? So I'm just curious if that's any of the topics that you've been around, or if you're hearing anything in any sort of level of construction, because it's a huge industry. And I do think there's a lot, like what you mentioned earlier, AI is going to probably take over a lot of the mundane tasks in your day-to-day life. But construction's also pretty mundane, but it's also labor intensive. So I'm wondering if AI is going to help us build stronger structures, better products. Yeah, that's sort of where my head's at with all of this.
No, I think that is a good one. Okay. Now, nerdy Lucas did some research on what it would take to build a space elevator, and and it's not possible right now because we don't have the materials that would be able to sustain this tensile strength needed to build like a, so in essence, we need some research on material design to figure out. And I was like, okay, that's a great, like maybe AI could help me figure out how to build a space elevator. So, we can get out of the gravity well and actually finally not have to shoot rockets up anymore. Anyways, little side topic. What One of the things I think that would be really fun is in construction, and Google tried this a while ago, the Google glasses. I know augmented reality is making much more progress now. They're quite heavy design still, but as they get lighter, it could be interesting to have a more connected construction site where maybe, the electrician is fully aware with the glasses on where they should be going next, what they should be working on, while over there the framer is putting up frames, the plumber is working on things. And they could be all coordinated by an AI that does like a kind of an overlay of where you are, where things should go. So there's less confusion on, when things should go where and where's everything located. That could be interesting. Similar to manufacturing. We talked about this a lot with manufacturing factories. Like you have people walking through the factory sometimes. So they're working on complex machines that they don't know all the details about. So being able to know, with the glasses on, this piece over here, the screw is getting loose, you need to do this, add oil over here, this piece needs some maintenance. Because if the factory ever stops because something failed, that would cost a lot of money. So being able to provide, in essence, not necessarily on-the-job training, but augmentation of the person there to show them, this wire should be routed over here, in order to follow code, it needs to be 1 foot away from this heat source, right? So I could see some like augmentation of workers there. And then to your original question on civil engineering, right? Strength of materials. I think that could be interesting. I do think, we're doing quite a good job as humans on figuring out what are the loads, what is the load balancing. I mean, the Romans did a great job too 2,000 years ago. So we've made some advancements. I'm sure we can make a lot more. So I can finally build my space elevator.
Yeah, I think civil engineer is going to be able to build a space elevator. That's good. I didn't even think about that though. Like with all these lenses coming in and being able to see different layers. But while you were talking, my mind went to like Boeing planes. And I'm curious, I bet AI is going to find a way to like kind of triple check things, triple check that everything's in place, everything's screwed correctly. I don't want to say supervisor, but be like an extra lens to building. And especially like I think planes it's kind of a big thing.
It's a hot topic for sure. Yeah. Yeah. I mean, I think one of the challenges that we have with AI is there needs to be a way for the AI to get the information, right? Like AI usually sits in some data center somewhere. For the AI to know that the bolt over here is loose, there needs to be a connection point. There needs to be a tool applied to that screw to show the system that it's slightly loose, right? And that's where currently the gap is. So one of the things we have been thinking about is like, can we get cameras? Can we use camera? Usually factory floors have cameras, for safety and whatnot. Can we use the cameras to see that, instead of doing a full rotation of the torque, only, a 3/4 rotation of the torque was applied, and that is below the standard for this given screw. So, that might raise like, can we use patterns just from visual recognition? Because, that's the easiest way we can get data right now is through the visual, and visual AI is getting quite good as well. Yeah. So there are examples like that, but you got to think about the connection point between how can I connect the thing that I care about to the data center that then thinks it through and knows, what the, and that's what GenAI does help, because GenAI is really good at the visual, right? Like I always knew that, X amount of torque needs to be applied, but now I'm actually able to connect the dots because I have that GenAI that can take the visual and interpret that this thing over here is a torque. And it can understand that it was applied to this bolt over there.
Interesting. Yeah. Can we talk a little bit more about that connection piece, the warehouse to the application?
And we can take a different example because I know not that many people in the tech world are in manufacturing. So a really good example is meetings. So until 2020, the famous coronavirus year, most meetings were in person without any computer present. And so AI, doesn't know much about meetings between people because meetings between people were usually not recorded. Enter March of 2020, everything's switching over to, Zoom, Google Meet, Microsoft Teams, and all of a sudden, pretty much every meeting is in some ways recorded. That allows AI to understand a lot more about how people meet, how humans talk to each other. But the connection piece needs to be there. The connection between, I wanna optimize meetings and I wanna optimize productivity out of meetings, but I have no way to know what is happening in meetings because they were never digital. So now, thanks to coronavirus, thanks to COVID, we have the connection. There's always pretty much now some sort of virtual component to a meeting, and we can now see that, this is how the meeting went. These are the 3 points discussed. These were the 2 action items agreed on. And, we agreed that we're going to meet again in 2 weeks. So the AI can capture that and bring it back to people. And we got to be able to make the connection between the outcome we want to achieve and the technology that can help us achieve that outcome. So in the factory floor, right there's a lot of machines are 40 years old, right, or 30 years old, and they're multi-million-dollar machines that are they're still running. Right, like I talked to a factory on the border, on the Mexican border, and the guy running it, he's like, "Look, we're building nails. Nails cost a fraction of a cent to make. If 1 out of 100 nails isn't great, that's fine with me. Nobody's going to raise a complaint. AI is not going to help me make better nails. But AI might help you predict when your machine is going to need maintenance, right? And that's important because if I need to shut down my plant for 3 hours because one of the machines in the chain is down, right, that has a huge impact. So that's where we can use, we've used like some vibration sensors, like we have used the video cameras to see if anything is wrong. And then just knowing from, the history of this kind of machine, it tends to have certain maintenance milestones that we need to hit. So there are certain things we can do.